In this video, we'll build a serverless REST API with Azure Functions only, from new project to Microsoft Azure deployment, and 100% cloud native, so don't miss it. Hey there and welcome to the Code Wrinkles channel. Building REST APIs is something that we do fairly often as developers, and we usually use ASP.NET Core to do this to an extent that it has become mainstream and it is for amateurs, but we'll bring everything to the next level as we'll build right now a serverless REST API with Azure Functions only, 100% cloud native. And if you think that what we'll build here is just a dummy HTTP triggered functions, then you are totally wrong. We'll build a fully functional CRUD endpoints in our Azure Functions. And to do this, we'll have to dive deeper into some very important topics like how do we use dependency injection in Azure Functions, how do we use Entity Framework Core in Azure Functions, and obviously also how do we use Azure Key Vault to safely store our secrets. Everything will be covered during this video. And believe me, this journey is not necessarily complicated, but it is paved with a lot of different challenges. So the goal here is to explain everything as clear as possible and as in-depth as possible so that you can go in your project and confidently use Azure Functions. So let's get to work. Usually in my day-to-day work, I like to always start by creating the needed Microsoft Azure resources. And that's why I have created a very basic setup where I have an SQL database, an SQL server, and a Key Vault and a storage account. And what we'll do here is we'll go on and create our Azure Function app. So we'll search for function, and this should be the one, and then click create. Now during the creation process, there are some important things that we need to take into considerations. First of all, the subscription and the resource group, that's everything fine. And the next thing is we need to give a name to our function app. So let's try with this one. And then there are some things that we need to be careful about. So the runtime stack, that's where we say exactly, okay, do we want to have .NET, Node.js, Python, Java, and so on and so forth. Obviously, we will want to have .NET. Now, there is the important part, like the version. When we think about function apps, there are actually two types of functions that can run in function apps. There are in-process functions that run in the same process as the host, and there are isolated functions that run in a different process, dedicated process, so not in the same process as the host. The thing here is that, for instance, in the in-process function in Microsoft Azure, they always support just LTS.NET releases. So it means that we would need to take here the .NET 6 because that one is an LTS. On the other hand, if we want to use isolated, then we have, or we can use also .NET 7, for instance, or releases that are not LTS. However, there are some differences between how in-process functions work and how isolated functions work, even to the code that we need to write. So in this case, or in this video, I will focus on in-process functions, and therefore I will choose this .NET 6 LTS. And then the region, I'll choose West Europe as always. The operating system, I want to be Windows, that's okay. Then let's click next for storage, and Azure Functions already also need a storage account. Now here by default they say, or the function says that they would, or it would like to create a new storage account, but I already have a storage account. So I will just choose this existing storage account and I will click here on next. Then enable public access. This is something that we want on by default in this case, because we want to be able to call our REST API from our Azure or from Postman, so outside the Azure function itself. Next to networking, here we'll leave everything as it is right now. I will also go on and create a new application insights. Then for diagnostics here, I would like to have this on disable. I don't want to integrate with GitHub Actions right now. Then just review the tags, review the function, and create it. Now that the function app is created, I'm back here in my resource group and I want to go on and go to this function app because there are some things that we need to configure here. First of all, we want to integrate this function app to use Azure Key Vault. And if you remember, in order to do this, we need to come here to identity and we want to enable this system assigned managed identity. So we'll just click on save here. We click on yes. And now I can copy this object principal ID. Now that I have this, the next step would be to go to the Azure Key Vault because we need to enable an access policy for this Azure function. So let's go to our Azure Key Vault resource and then we need to go to access policies, and here we need to add an access policy for our system assigned managed identity that we have assigned to the function app. We'll just click here on create. We will need just get and list because we will need to be able to also read the value. Then next, here we can search by the object principal ID that we have copied earlier, and that's our function app. So next, and right now it should be okay. Now let's move over to Visual Studio and create a new Azure Functions project. Let's name it Serverless REST YouTube. And here there's another choice. Once again, we have defined when we created the Azure function that we need to use .NET 6 because we wanted to have an in-process functions here. And that's why here we also need to make sure that we choose .NET 6 because that's what we want to use. And then each function has different triggers on which it can get executed. And to create a REST API, what we need to do is to create an HttpTrigger. So this is actually what we have here by default. And then we can simply just click create. Okay, so we have here our first function, but what I would like to do is simply delete it. Right now, I want us to actually concentrate on two very important things, like this host.json file and this local.settings.json files. They are very important. Now, the host.json file is a JSON file where we can configure different options for the host itself. So once we deploy these Azure functions, the options or the things that we configure here in the host.json will actually be also executed and will take effect also in the Azure function that runs in our Azure web app. However, there is also this local.settings.json file. And this file is very important because this file is very useful to you if you want to debug, or when you debug your Azure functions locally, you can specify, for instance, what options do you need or what settings do you need for that Azure function to work properly. Now, in our case, what we will need is the Key Vault URL. So what we'll do is we'll add the Key Vault URL here in this local.settings.json. So let's have a comma here and just add here our new options, which is the Key Vault URL. So this means that we need to set the exact same option also in our Azure portal. So let's go back to the Azure portal and let's open once again our function app. And to configure the exact same options or settings that you have in your local environment for debugging in your function app, you need to come here to this configuration. And in the function app configuration, you will see just in a few seconds that you can add your own configuration information to it. So the only thing that we need to do here is new application setting. Then for the name, we need to use the exact same name that we have used locally because our code will rely on this specific name. And obviously we'll also need to use the exact same URL because we'll use the exact same Azure Key Vault. So let's click on OK and let's click on save. Okay, let's move back to Visual Studio right now. Let's close all these files that we have here. And the next step that we need to think about here is we need to install a bunch of NuGet packages that we will use throughout this video. So let me go here to manage NuGet packages. And let's start. First, we'll use Azure Identity because we will use Azure Identity to create a new default credential so that we will be able to access the Azure Key Vault. So let's just install this one. Then what we'll also need is security.keyvault.secrets. So it's this one because we need to be able to read the secrets. And then we'll need this Microsoft.Azure.function extensions. So that's the next one that we'll need. And then we need a bunch of packages for Microsoft Entity Framework Core. We'll need the first one. And here's one other caveat where we need to be very careful. Remember that we have our function runtime using .NET, so the .NET 6, so the LTS version of that, the current LTS version by the time of recording. So this means that we need to be careful because Entity Framework, we need to also install the .NET 6 version. So I will install the latest .NET 6 version of that. So let's install. And then we'll also need the SQL Server. And once again, we need to be careful exactly at the same thing. We want to install the .NET 6 version and we will choose the latest .NET 6 version or EF6 version. Let's install and we should be good to go right now. Next, we can create the classes that we will need for this REST API to work. And first of all, we need obviously a resource on which we want to create CRUD endpoints. And we'll keep it simple and we'll think about a product. So we call this class product and it will be a product.cs. I would also like to make it public, even though internal should also work. And here I'll just copy in some properties that I have already prepared, like an int ID, name, and a price. Now that we have this, we also need a DbContext to be able to write or to persist new products to the database and also update them or read them. So let's add here a new class and I'll call it app DbContext. Let's also make it public. Let's inherit the DbContext and add the using statements that are missing. And then we will configure here a very regular DbContext, just we are accustomed to in ASP.NET Core, where we'll take in some DbContext options and we'll pass them to the base class. And we'll just have here a DB set for the products. This time we won't perform any migrations. The database in Azure is already up to date with the latest schema that we would need. I'll be honest with you, and I have prepared this before this video using an ASP.NET Core project to add the migrations and update the database. The reason for this is that to use everything in Azure Functions requires a lot more tweaking on Entity Framework Core with Design Time Factory and running migrations and updating the database via code, and that would be totally outside the scope of this video. But if you would like me to cover this topic more in depth, then please let me know in the comments and I'll consider creating a video on this. Now let's move on and take a look at how we can configure and use dependency injection in our in-process Azure function. To add dependency injection to our in-process Azure functions, we need to configure the host when it starts up. To do this, we will also need the help of a new class that we will add just now. To create add new class, and we will call this class startup, because this is the class where we define some things that need to be added during the startup process of the host. And the way we can make Azure Functions aware about the fact that we want to configure the host, we need to inherit this base class, which is the functions startup. That class contains an abstract method that we need to implement. That method is this public override void configure, and we have this iFunction host builder, which is similar to the web application builder in the sense that we can configure the builder. The only thing that we would like to do in this builder is to add DbContext to the dependency injection container so that we can inject it in the functions that we will create. Now, in order to read or to get or to create an instance of the DbContext or to add it to the dependency injection container, we need to read the connection string. And to read the connection string, we need to connect to Azure Key Vault. So let's take this step by step. First of all, we will need to read this Key Vault URL from our settings. And the way we do this in Azure Functions is, or one way that we could do this in Azure Functions is to use this environment and then get environment variable. Because the settings that you set in the local settings.json files, they will be available as environment variables. And it also goes the same to the Azure portal, so the settings that you set in the configuration as an application setting will be available to the function itself as environment variables. So the code that we've written here will work both when we debug locally but also when we deploy to Azure. The next step is to connect to our Azure Key Vault, and to be able to connect to the Azure Key Vault, we need what is called a secrets client. So that's exactly what we create here. So new secret client, and here we provide the URI that we have had earlier and the default Azure credential. The next logical step would be to just read the secret that is of interest to us, and that is this SQL. Now here I say that this is a little bit funny because on the secret client we say this get secret, and if we provide a key for the secret, and then we get this value, which is, if we hover the mouse on this, is this a Key Vault secret. Now this Key Vault secret, which has the name value here, has another property that's also called value, and that's the actual string that we are looking for, in our case the connection string. So I know it's a little bit funny, but hey, that's how it works. And once we have everything in place, we can add the DbContext just like we do normally in an ASP.NET Core application with builder, services, add DbContext, and then options use SQL Server. Here we are missing probably a using statement that we will need. So let's just add it, and now all error disappeared. So we have configured the host, we are ready with this. Now we would need to create some Azure functions that represent our API endpoints, and this bears a little bit more thought. So what we'll have in the end is 5 CRUD operations: get all, get by ID, create, update, and delete. And if we think a little bit about the URLs that we will need for these REST endpoints or for these CRUD actions, we'll have just 2 different REST endpoints or 2 different URLs. We'll have products and we'll have product/ID. Behind these 2 URLs, we can group all the CRUD actions that we need. Under products, we can group the create and the get all endpoints, and under products/ID, we can group the update, the delete, and the get by ID. Therefore, I'll create here 2 different Azure functions. Each one will be responsible to handle the requests for a certain URL. Obviously, you could do this even differently. You could create an Azure function for each CRUD endpoint. That would also be totally fine. So you have full freedom to design your functions the way that you think is best for your specific scenario. Now let's get back to work. Let's start with the first endpoint, and remember we want to have here an Azure function for this get all and create. So let's click here on add, and here you see that we have the option to add a new Azure function, and that's exactly what we want to click. And I will still keep here Azure function. Now the only thing is I will need to provide a name, and I will use this products get all create so that I know exactly for which endpoints or for which CRUD operations this function is responsible. So let's click add, and here we are presented with this very simple wizard. From here we will choose this HttpTrigger because we want this to be a REST API, so we will receive HTTP calls, therefore we need an HttpTrigger. And then the authorization level, we have to create here function on anonymous or admin. Now this authorization level is actually important. We can also change it afterwards, so there's no problem with that, and we'll see exactly where we can do that. However, the main idea is that if we choose here function, it means that for each call that we make to our Azure function, so from a client, in our case from Postman, we would also need to provide a key. Now a key we can generate from the function app in Microsoft Azure, and we can use this key now. And you also have a master key, and that would correspond to the admin. Now, for now, we will want to just to concentrate on this very simple setup and make everything work. So we'll choose as authorization level this anonymous that doesn't require any type of key or any type of authorization to be able to perform the request. Obviously, I want to emphasize this is not a secure approach. And if you're building this in production, you would have to choose here authorization level function, and then you work with keys. And even better, you would probably need to have an API gateway in front of this and make all the authorization at the API gateway level, not on the Azure function itself. So let's click add. And here we have added this very basic Azure function. We'll probably delete a lot of things that we have here, but I would like to go through some steps that we need to perform here. Now, the very first thing that we need to do is we need to change a little bit how this class looks like, because we need to be able to inject our entity framework or DbContext. First of all, we just need to make our class to be non-static. The reason why we want to do this is because obviously we'll need to provide a DbContext, a private field for a DbContext, then we will get a DbContext injected and we assign it to our private field so that we can use it in the function here. Now, if it comes to the function itself, I just want to spare a few words about what we have here. So first of all, we have this attribute. Basically, this is an HTTP request, and that's decorated with an attribute. I know it's quite long, but that's the main idea of the attribute. You have to specify a lot of different things in this specific trigger attribute. Now, the first thing that we specify in this attribute is the authorization level. And I told you earlier that we can customize that or we can change that. And here is where you can change it. So if I want to change this to be authorization level function, then I could simply just use this enum and choose from here function. Then the next thing that we find here in the trigger is the HTTP actions to which this function will be triggered. So in this case, we have get and post, which corresponds to what we want to have in this function. Because if we have a get, we want to get all the products, and if we have a post, we want to create a new product. And now for the route here, this is also a very important part, because here is where you can customize your exact route, and we'll see a little bit later, even including routing parameters. Now what we need in this case, our route will be products. Now by default, the Azure function will work in a way that it will also have the API before product, so it will in the end be /API/product. But for us, it's important right now just to concentrate on this products part. And then we also have this iLogger that will get injected by the host directly into this function. Now we will not use the logger right now, so I will just delete this. Now, as a next point, I would like to implement the logic for our Azure function. So I will delete everything that we have here, and I will replace with the code that I have already prepared. And I will go to this code line by line. Obviously, first of all, we need to make this method non-static because it needs to be an instance method so that we have access to the private field. And in this case, the logic that we perform here is very easy. There are only one or two things that we need to be a little bit more careful about. Now, the thing is that we will have here a little bit of different logic depending exactly if we have a get or if we have a post. And that's why we have this if. So we say that if the action for this HTTP request is post, then in this case, we want to create a new product. To create a new product, we need to read the HTTP body and to create a product from that specific body. Now here in Azure Functions, we don't get this by default like we do it in ASP.NET Core. So that's why we create first of all a stream reader and we read the body with that specific stream reader. And then we use JSON convert and deserialize object, and we use this generic version of deserialized object because we want to deserialize this to a specific product. And obviously we provide here the stream reader that we get here. Now this means that when we finish reading here, we have a new product, as you can see if we hover the mouse over it. And then we can use the DbContext to add the product, and then we can save the changes and everything is done. The only thing that still remains to do is to return something. Now obviously we need to also return an iAction result, but the way that we usually return from ASP.NET Core APIs is not 100% exactly the same, so we will have to return we will need to create a new instance of created result. Now in this created result you would have to specify the fully qualified URL through which you can access the newly created resource. For simplicity reasons, I have specified here only this product. And then the body that will be placed in the HTTP response. And then the other thing that we need to do here is if it is not a post and this function gets executed, it means that it is a get. And in that case, the only thing that we want to do is to get all the products. So we have this toList async. We need to just use Microsoft Entity Framework. And once we have all these products, we can return an OK object result and with that specific product. And with this, our Azure function is ready. So let's create a new Azure function here. So add new and we'll create Azure function. The name of the function this time will be products get by ID update delete, because these are the CRUD actions that we want to be handled in this specific function. So we can click add. Here once again we'll have this HttpTrigger. We'll check, or we'll take the easy one or the simple one without open API, and then we will use also anonymous as authorization level, and then we will just click add. And here we will need to perform mostly exactly the same things that we have done earlier. So remove here the static, also remove it from the method so that we don't get confused. Then let's add here the private field and the constructor. Let's remove the logger because we will not use the logger in this case. This time we will also need to customize a little bit what actions do we want to listen to. Because here we have the get. In that case it is a get by ID, but then we want to have a put, and then we would also like to have a delete. And then we also need to specify the route. In this case, our route will also have a routing parameter like this one. Let's maybe get these things on a new line. So route, it would be here products/ID. Here this ID, this is a routing parameter, and binding parameters in HTTP triggers works more or less exactly the same that we are accustomed in ASP.NET Core, so that's why we specify this ID in curly braces. Now, just like in ASP.NET Core, if we have this route param, it means that we also have to specify for it this int ID so that it could bind to this integer ID so that we can get that information and work with that. And now let's get rid of all this stuff here and we'll replace this with our custom logic. Now, what we have here, for instance, is okay, if the method is get, then we want to get by ID. So in this case, we have this products first or default async. If it is null, then we return a not found result. Otherwise, we return an OK object result. Then the second scenario that would be possible is that if the method is put, it means that we need to do an update. In that case, just like we did previously, it means that we need to also read the body. So we need a stream reader. Then we use this JSON convert and we deserialize to our product. And then we just also set the ID from the identifier that we have in the route so that we make sure that we update the product that needs to be updated. And then we'll update database, save the changes, and we return a new OK object result. If we want to delete, on the other hand, what we'll do is once again, we'll look for the product in the database. And then if the product is null, we once again return a not found result. But if we find this product, we just remove it, we save the changes, and then we return a no content result. Now let's go back here a little bit because we have forgotten here a comma, but right now we should be actually good to go. Everything should be up and running and we can test this application. However, now that I'm about to run this application, I remember that I forgot something very important, and it has to do with dependency injection. That's why I'm back here in the startup class, because there is one other step that we need to perform for things to work. So by default, the Azure Functions host will not know that, okay, we have this startup class, where we have overridden this configure method that it needs to execute. So we need to specify this using this attribute, which is the function startup, and we see when we specify exactly where the startup class is that we want to execute the configure method on when the host is created and configured. And now we should be really ready to go with all the needed information, so let's run the application. So now the application is up and running, and as you can see, we already have two functions, so we see that already in the console, and we also see the URL with the available HTTP actions or methods that are available for those specific URLs. So let's move over to Postman, where I have already created this. So we have this local host and then the port and API/products, and let's create a new product. And here, let's say then code wrinkles, let's maybe put here a different price. So we'll just test here locally these two endpoints. So the create and the get all endpoints. And then when we deploy to Azure, we'll test also the other endpoints. And here we have the result. We see that the resource was created with this ID 5. Let's also test this get all. And we see that we have these two products that are created. And this is the one that we have just created. And let's maybe also even try this other one with the ID, with the get, and it should be also return this product that was just created. So we see that everything is working right now locally. Let's move back here. Let's stop this Azure Functions because we don't want to run it anymore. And what I would like to do here right now is to deploy it to Azure. And I will do this deployment from Visual Studio. So I will click here on Publish, and then I'll choose here Azure because in Azure is where I want to publish. I want to publish to an Azure Function App that runs on Windows because that's what I have. And then here you see it's loading, and we can already see that it sees the function app that I already have. And then I just click here on Finish, and it will do the deployment, and I will be just right back when the deployment is completed. So the function app is now deployed to Microsoft Azure, and this is the URL that we have here in Microsoft Azure. So I will go over to Postman. First, let's run this get all, and we see that it returns the exact same result. Let's maybe also run get by ID, so we just specify an identifier, and that should be okay. Now let's also test the update one. So let's have it with put. Let's just replace the URL. And here I would like to have the name. It would be like this. So then, and this other one, let's make it 220. And then let's click just send. And right now we are making the calls directly to our Azure Function App, as you can see here in that URL. And now let's make a get once again. And we know that it is with ID 5, and we should be able to see the updated product, which is indeed the case. We see the updated value and also the name was updated. And last but not least, let's also try to delete. So let's just click on delete, and it was 204 no content, so deleted. Let's now maybe try to another one get, but let's get all the products. So let's send the request, and in this case we see that once again we just have one product in the database because the other one is deleted. That's it, you made it till the end. Don't forget to hit the thumbs up button and like this video so that others might discover it easier. And if you're for the first time on the channel, hit the subscribe button and the notification bell so that you are always notified when there's new content here. And if you have any question or just want to get in touch with me, don't be shy and head over to the comment section and leave me a comment. I would be more than happy to get in touch with you. This being said, thank you very much for watching, and until the next time, I wish you the very best.